do have great pleasure in introducing our last speaker. In fact, I've actually got a confession to make first, and that was that our next speaker, Neil Thompson, I actually used part of his introduction yesterday when I introduced Matt Goff. Now, to be fair, both are middle-aged white men from London who like heavy music, but as a middle-aged white person from Australia, I still think that probably is a little bit of bigotry in there. So my apologies to Matt yesterday, but I'm going to take a leaf out of Arj Barker's book and use some of the same content twice. And I'm now going to say that when I spoke to Neil and asked him, hey, what have you loved about lockdown? One of the things he said was his love of music, and he got caught on camera once wearing a Metallica t-shirt. And one of his members of the senior management going like, oh, you know, are you a Metallica fan? And he goes, well, just being able to play a couple of tunes count as being a fan, picked up the axe and proceeded to play Metallica to senior management. The other thing that I did find out about Neil when I was on this interview with him, because I got to peer into his home, and what I saw was this podcasting stuff, and I found out about the great podcast he runs called the Digital Twin Fan Club. He's going to be talking us to a little bit about digital twins and the UK's approach to digital twins now. But if you haven't checked it out, I highly encourage you to check out the Digital Twin Fan Club. It's available on SoundCloud. And what I might even do while Neil is talking is just drop a link of that into the chat thread so other people could check it out. Without further ado, please welcome Neil Thompson to the screen.
Hi, everyone. Thank you very much for that great introduction. Yes, get on to the Digital Twin Fan Club. We just on that for a moment. Our latest episode is part 2 of an interview with Professor Michael Greaves, who worked with NASA and still does, but many years ago, and created the term digital twin. And his interview is fascinating in terms of not very interfaces with NASA is always interesting. So do get on there. So hello everyone. My name is Neil Thompson, and I'm going to speak to you about a bit about myself. And then I'm going to talk about the work that the Construction Innovation Hub is doing and some of the UK industry activity. And then I'm going to give you my Atkins view of how we're responding to that. And what I want you to leave feeling today is at least some points on, I've shared what we do. I'm going to be quite transparent with you, maybe share some things we're not supposed to, but what I want you to learn from that is there's starting points and there's things to think about as you leave this conference today in terms of digital transformation, not just for your industry, but for your organizations as well. So a brief introduction to myself. So my name is Neil Thompson. I'm seconded to the Centre for Digital Britain as their programme lead for the Construction Innovation Hub, and more detail about that in a moment. I also have other roles. So I'm a director of digital construction at Atkins, where I look after 2 things. One is for UK and Europe is our structuring of our service lines for digital twins. How are we going to augment the ability for our client organisations to build digital twins, and more of that later. Also, a global lead for the integrator. So looking at how does we reposition our value chain of all the work that we do into an integrator model, and I do cover a bit of that as well. And I guess last one to highlight is that I have an associate professor position at University College London, and I guess what we want to talk about is essentially survival of organisations in our industry. So my career, my research and work to date has been about helping organisations survive through the disruption of digital transformation. So I thought I'd share with you some initial thoughts. And I think the interesting thing is, in terms of our digital transformation journey so far, is I've found a problem, and that problem is. And apologies, I found this tweet on Twitter on the left-hand side here. It's from an architecture school, and it says, happy to be back from impacts of the pandemic and starting to get students back to school, and noticed, and you see under the red circle there, that there's drawing boards in the classroom. And on the other side is if you type construction 2020 into Google, one of the first images you'll find is, we've got some men on site, One has a drone, which is cool. It seems that we're up to date, but then the other guy is holding a sheet of paper. And our digital transformation to date, and I'm talking generally, and this is globally, is we've been applying technology to augment our paper process. We're still drawing drawings, albeit digitally, to hand over to builders to build from. And that's I think it's a valid step. We can only, the best thing is to apply technology to your context, but we're not using computers in a way that they're really designed to use. There's things that humans are really good at, and there's things that computers that are really good at. And communicating on information, measuring and validating things is something that a computer can do really well. So I guess what I mean here in terms of going forward is less about human to human communication across the stages and more machine to machine communication. So I've not seen your Autodesk presentations, but for those that have seen Autodesk presentations about the future of design, you'll see lots of examples about generative design. So instead of us instead of creating one design and trying to implement that design and value engineer it, having the ability to create, there's a great quote from, I forget who the person is, so apologies, is, creating 1,000 designs a day and then select, our design process is more using the outputs from that generative design to select the appropriate and optimal selection. So, for example, in that generative design space, it's used heavily in creating stadiums, sports stadiums, for example. So that's part of that, using computers to do the main bulk of the design from a generative design perspective. Then it's handed over into a manufacturing space, and this is where we start getting into the work that happens at CDBB and Cambridge University and Bridonwood, etc. And it's about splitting that generative design into a kit of parts so we can assemble those off-site and sometimes on-site. There's a debate to be had there. We can talk about that later. But using manufacturing techniques to push up the productivity and quality. And lastly, it's about assembly. So instead of talking about building, we're talking about assembling something. That picture there is from the work that I led last year, where we're applying collaborative robotics in complex environments, and we've developed ways of integrating the design environment to use it as a way of creating machine readable code that can be fed into collaborative robotics to position things, undo bolts, and all that type of stuff. So, moving from paper to paper, human to human, to data, machine to machine is a place that we're in now. I think if you look at what Craig was presenting, with utilization of the cloud and distributing the work that we do. We're not doing work on desktops. We're doing mostly work on laptops, and they're connected to the internet and what have you. I'll cover that more in a moment. So there's sort of the lay of the land, and it made me reflect on when I was presenting at this conference 7 years ago. It was in 2013, I believe, and this is a picture from that. So slightly vain putting a picture of myself up, but I've flicked through my phone to pick one up, and one of my opening comments was a quote from Neil Postman, who's an academic from America, and he made lots of predictions about the internet. He predicted internet banking, for example, before internet banking was a thing. And he said that technological change is not additive, it's ecological. A new technology does not merely add something, it changes everything. So although we sort of broke that rule in the previous example where we've applied technology to the existing process and we haven't really made an impact on a global level in terms of productivity because we've just digitized paper. But the interesting thing is it's given us the opportunity in the platform to apply the automation where we can change everything. And just reflecting on my previous presentation, just to show you that it does change everything. For those that were there, you might remember that I got my phone, I plugged it into the AV system, and I showed you an app that was only available in London at the time called Citymapper. So, London, the city, opened up its data. Citymapper as a technology company came and integrated that data so you can have one view into all the types of modes of transport in London City, and you can use that to At the time, it was just a route mapper, but now Citymapper is available in Sydney and Melbourne. It's available globally, and they do interesting things like a subscription service for travel. So in London, I can pay, I think it's £30 a week, and I can use any mode of transport in London, including a special bus service that Citymapper creates that it can analyze the gaps in the transport system, and it deploys a bus system to fill that gap. And you can use that as part of your subscription service. So this is what I mean about technology is an additive. It's ecological. It changes everything. The Citymap has changed how we navigate cities globally. It started 7 years ago in London, and it's now where it is today. Just to I guess showing you about, I was telling the story of, we're integrating data on a transport system. How do we integrate data in the construction industry, and how are we going to go about doing that, which gets us into the digital twin conversation. So we're making progress from that respect. The other thing I mentioned, and this is from the slide deck, is I spoke about this journey from the 1960s through to today. Today being 7 years ago, we went from men in tweed jackets, bow ties, PhDs, using computers, all the way through to school children building robots out on mobile phones. It's quite interesting, because when you map that into what's happened in the past 7 years, and I think this slide's quite interesting because it makes me laugh, is that at the time I was working at Balfour Beatty, and our pride and joy was having a stainless steel box on a building site with a desktop computer in to provide you access to the 3D model. Today, we work with a startup here in London called XYZ Reality, where they have an augmented reality hard hat with a transparent visor, and you can augment the 3D model onto the building site, so you can see the gaps or where things don't quite fit. In 7 years, we've gone from desktop computer in a metal box to allow access to drawings and 3D models, through to a helmet that you can wear wirelessly and be able to augment the 3D model onto the site. And that's what's happened in the past 7 years, is the ability, the increases in computing power, its ease of use, integration of data, and the ability to process those models have gone that far. What does the next 10 years look like? So that's a bit of background, bit of reflection on what happened before, and I'm going to jump into what the Construction Innovation Hub are up to. So the mission of the hub, which is funded by UK government, is to bring two things together. One is manufacturing techniques using modern methods of construction and things that we can learn from advanced manufacturing technologies in terms of automotive, aerospace, etc., and digital ways of working, utilizing digital to do that. And with the prime purpose of, one, boosting productivity, creating an export market for the UK, and ultimately optimizing built assets to perform its best in terms of its context of its benefits to society. So making sure that schools are the appropriate environments to learn, making sure that hospitals are functional spaces to improve people's well-being, etc. So what do we do? We split this world of manufacturing and digital into four themes. Those four themes are value, manufacturing, assurance, and digital. So value is about business models, contracts, understanding. So, for example, I was talking about the integrator role. How we talk about changing, and it was a conversation that was happening in the panel yesterday. A conversation about how do we change our commercial relationships in terms of being able to share risk, being able to create markets for and incentives to share data, to deal with some of the dysfunction of the behaviours that we have. How do we get people to have skin in the game to make sure that they are delivering the appropriate quality on time, etc. And that the value stream is about how do we go about doing that. So we've created a thing called a value toolkit that allows client organizations to think about the outcomes and the performance measures that they need to be able to align their supply chain to in order to create a new conversation about how can we create new commercial agreements to make sure that we, supply chain behavior, making sure that that's positive, progressive, collaborative, etc. There's manufacturing. I should mention, apologies, I missed a slide out here. So the Construction Innovation Hub is built up of 3 partners. One is the Manufacturing Technology Center. So imagine a big warehouse full of technology out of your wildest dreams in terms of application of robotics and what have you, there at the MTC. There's the Building Research Establishment. So they do a couple of things. They develop technologies, but they also have lots of testing facilities in terms of making sure they can test construction products to their destruction. So there's assurance. So for example, to go through a manufacturing process, you need valid checks and balances in terms of how do you certify certain products and making sure that the products they're using are appropriate. And lastly, digital. And the analogy that I like to use is we're doing a few things. I like to use Amazon as an example. Is we're looking at the warehousing and the logistics systems of Amazon, and that's the manufacturing piece and the assurance piece. But on the other side, in terms of value and digital, we need the website. You need that functional digital system to be able to feed your customers through into your logistics system. Amazon would be pretty useless without its website. Let's put it that way. So we do over 200 projects in the Construction Innovation Hub. So I can't go through all of them. All I'm going to do is pick out some key ones. The flagship one for me is our platform construction system. So looking at creating volumetric systems for buildings and working, essentially providing guidance to industry around how can you split your designs into a volumetric system. So we look at the different type of sub-assemblies and systems that we need to create. Here we're with the fellow building services and MEP folks who are talking about how can you integrate modularization of plant rooms and risers into the fabric of the building? How far can that integration go? And then that modularization being integrated into a much wider space. So can a classroom turn up on the back of a truck with everything on? I know we've seen examples of that, but I guess the key point here is creating a capability. So one, the UK industry can be self-sufficient in that space. So in terms of manufacturing these things in the country, there's also broadening that capability and lowering the barrier of entry so more people can play. At this moment in time, it's a very expensive endeavor to make the capital investment to go and build factories and then build your capability off site and using those tools. So there's the methodology for doing that. I guess more deeply on that, we work with 40 industry partners to look at all the way from design, contractors, and products, and they come together as a single integrator to build a proof of concept demonstrator of how we're integrating these elements on the left hand side here. So pardon me. As I say, we've got great examples in industry of modularizing particular areas, and the MEP world is streets ahead, really speaking honestly from my perspective. This industry has been on that journey for a long time. I remember 7 years ago being at your conference, and the examples, I forget the company of entering the prefabrication space for the first time. I'm forgetting the company's name, and apologies if you're there. And you gave a great example of we gave this a go for the first time and the benefits that they had. As I say, it's preaching to a converted audience here. But imagine expanding those capabilities in that platform construction piece. So that's the platform construction system. In terms of just 3 other key projects, and some of these I'm going to expand on, I'm going to go from the right-hand side to the left. So the right-hand side has this 2 aspects, and this is from the NTC. So this is using robotics to, how can you use large robotics to place large assemblies on the building site accurately. So developing the control systems, developing the systems that connects that design through to the building site, and making sure you've got the assurance systems to say, the great thing about using machines to deliver parts of our work is that has that work been done is an easier thing to check. You don't have to go and ask somebody on site, did you do that today? You can query the plants and say, what operations did it did today? What assets did it pick up and put into place? And it'd be able to tell you that. So there's interesting aspects from an automation of reporting perspective. There's another project there at MTC about what they call robot batteries. So, sorry, that is the robot batteries project. I'm sorry, it's called the Big Yellow Robots. So the Big Yellow Robots is about how do you about getting people out of operating plants and machinery, having control interfaces that are remote, so we can get people A, out of harm's way, but B, you know, we don't want to be having humans sitting in cabins all day. We want them to be working from a much cleaner environment. In the middle, we have two digital twin demonstrator projects. There's one at the BRE where they've filled a building full of sensors, although not much use when there's a pandemic on and there's nobody in the building. But yeah, we have a building that's kitted out with sensors in Watford. Also on the other side, so in CDBB, we have a demonstrator as part of the University of Cambridge, in West Cambridge, and there's a series of buildings and looking at, so if you've got 7 buildings that are kitted up with sensors, how would you go about connecting all that data together to make insight? So utilizing technology that controls the data for tracking the transport system in Cambridge, using that technology, a little bit like Citymapper, is a very similar technology, but instead of it being buses and bikes and all that lovely stuff, it's pumps and telemetry of a building. And then the final piece here, we do an element of this work. So there's a thing called the National Digital Twin Program, which is another program in CDBB. As part of creating this document, so the pathway towards an information management framework, I guess the simplest description of this is, you know, we have the internet. We start the journey of the internet is where we started with connecting mainframe computers to university laboratories, desktop computers at home, mobile phones, you know, and then sort of smart device. The space that we're in now from an internet perspective is the IoT and smart devices in our home. The information management framework is about extending internet technology into connecting infrastructure to the internet, and it suggests how you can go about doing that. So that's a report that's available on the CDBB website. If you type in the pathway towards information management framework onto Google, you'll find it. But in there, it sets out some of the work that we need to do to standardize data, to connect different data sets together. That's one of the projects that we're on. So just some highlight projects for you. So in terms of the Construction Innovation Hub aspect, go to the website, explore constructioninnovationhub.org.uk, and we publish everything that we do there. Follow us on Twitter, CIH_hub, and you know, transforming construction doesn't have to happen in the UK. We're very happy to share with the rest of the world. So please come along and check. My next section, I'm going to jump straight into, because I've got quite a lot to cover, is about essentially the Atkins response to all of that stuff. Manufacturing and digital twins is the main piece here. And the first thing to mention is, in terms of the digital twin space, we have to think about the broader aspect of digital for the built environment. And one of the things we have to appreciate is most of the built environment is built already. Maybe that's the wrong way to say it, but you know, 95% of all the things that we're going to apply from a digital perspective, those assets are already going to exist, and the building part is actually quite small. So this graphic sort of represents from a digital twin perspective, we're starting from an asset management focus in its use and operations, and then there is an aspect of design, and we'll cover that. So in Atkins, we have a basic test, because obviously the digital twin concept is quite a difficult thing to grasp. So from our business development perspective, I talk to clients and our people that talk to clients about this. There's two basic questions. You know, is there a data connection between the virtual and the physical, and does it drive decision making? And on top of that, does it require an integration of data and technology? If the answer to those questions is yes, then it's probably going to be a digital twin related project. And what we did in terms of a starting point is this is about a year ago now, maybe a bit more. We teamed up with the Institute of Engineering and Technology and set up a maturity spectrum for looking at twins. So what we did in terms of taking stock of what we do with our clients and internally is, well, how can we create a maturity model around digital twins? And this is here. So if you type in IET digital twins for the built environment, that PDF will be there for you. I do invite you to go and look at that, because what it does is sets out a clear framework for taking stock of what you do digitally. And there's 6 elements to that. Element 0 to element 5. Element 0 is more about capturing your reality. How do we go about having a digital view of what we do? And that could be anything from taking a picture all the way through to very highly detailed laser scans and everything in between. Element 1 is about the 3D model and how that model is turned into something that can be showing intent for design, for example. Element 2 is then about attaching data to that. So you have a model that's intelligent in terms of a snapshot in time. Element 3 is about having a connection, albeit one way, into a 3D environment. And elements 4 and 5 is more about different types of connectivity. So element 5 is essentially our unicorn state of this digital twin that's autonomous, uses AI and can control systems without any human intervention. So please go and take a look at that. Have a look at it in context of your organization. I think it will help you think about, well, how do we ingest data? How do we do something with that data? And then how do we connect that data with other data sets? So that's where we started. And from there, we then created a services lifecycle. So if anyone's seen a system V diagram before, that's essentially the bottom part of this. We call it the digital ripple. But essentially using the use case and need of an intervention on an asset. So let's say a wastewater treatment works, and extending that. We want to extend this wastewater treatment works. We have to go through a process of setting requirements and due diligence and integrating data to start understanding what you have. If you have an existing water treatment works, you have to extend the use of that. You have to use those, capture the reality of it, and then start building a design. So this diagram has 4 quadrants. In the bottom left-hand corner, you can see a picture of that's actually a virtual design. That's not an actual picture of a highway in America. That's a virtual one. So that's our design space. That is where we take our requirements, create the boundaries. If we're in the generative design space, that we'll be writing the scripts around the boundaries of the requirements where we can generate that design. Once you've generated that design, you could then move up to the top left-hand corner of this diagram. It's about simulation. So we're simulating the performance of the final asset because we need to understand how it works going forward in operations. And then once you have a base design and you've simulated that in reality, you've then got this crossover point where you've got as planned in terms of your business case, but then also as simulated as part of your operated asset. And then you move into delivery and what we call rehearsal. Rehearsal is all about what we call digital rehearsal. So it's about planning that work. Delivering infrastructure is really complex and it takes time. It takes time. It's against the laws of nature, and those laws are chaotic. So we have to be adaptive to change. You're never going to have a perfect as planned and as simulated solution at that point where that line is. It's always going to change. You just need an effective way to digitally rehearse what you do to manage that change. So as you can imagine, the reason why it diverges is as you design an extension to your wastewater treatment works, you're moving slightly away from reality. You're moving away from that digital and physical connection. You move away from that. You set what that model is going to be, what your design is going to be, and then you're slowly bringing that. So everything is virtual in that sense in terms of your intervention. But what you do as you reach the point, you then start converging it back into reality as you build and complete and commission. So the other side of this conscience, we've got top left hand side is a piece of technology called Safety Base. So essentially created a knowledge management system for safety data. www.safetybase.org, safety space, safety spelt with an I, base as in database. Check that out. I should have put a link on there. Maybe share that later. And then on the bottom left-hand corner is essentially the parts of the digital twin that you can kick. So your interfaces with decision making. So it be even a mission room or augmented reality, but it's that space where you're building things in reality and that physical interface with the digital twin. So that's our digital twin services lifecycle. We run through that one, and the important thing here is that golden thread through the middle. So we use an information connected data ecosystem to bring those together, which I'll cover more in a moment. So essentially, broken up the things that we do into three parts, and the top part and the bottom part is the bit I like to. They're the parts of the digital twin that you can kick. So the top part is essentially the user interface. It's either on a tablet PC, it's on a big projected screen, it's on a big touch screen, it's in an augmented helmet and what have you. And it's all about designing the task that you're doing around that user experience. The bottom part is essentially the sensors, the compute, and the storage and all that and all that stuff. Although quite boring, but the plumbing of digital twins is really important. And then the middle piece is essentially how you tie that physical infrastructure of data collection and storage through to its interfaces, all that data integration of different tools. For example, Forge is a great example of something that you tie into a broader ecosystem, and that's all that integration of technology piece. And that's where we operate. We operate as a service designer, we operate as a solutions integrator, tying technologies together, but we also provide the managed services to be able to tie those pieces together. So in terms of what it means for our services, it sort of splits into 4 areas. So in terms of strategy, helping clients and people like yourselves develop a strategy to develop the implementation of digital twins. We also do about capture, so a current asset conditioning, for example. So moving away from talking about surveying and just handing over plans and things to clients through to actually providing an ability around condition monitoring and understanding the actual condition of your assets. So moving away from surveying and throwing over data with no purpose to answering particular questions about the quality of an asset, and that's in our capturing space. Third is about integration. So we talk about information and data management, moving that over through to the design of user experiences and data orchestration to achieve that. So one of the things the way that we see it is, what data do I need to make a particular decision? That is, the decision of how can we make this water treatment works more efficient? How can we make the pumps more efficient? That basically breaks down into an equation of different data that you need to add together to answer that question. What does that data life cycle look like? And one of the things worth doing is, think about the decisions that you need to make. Sit down with your team in a room with Post-its and say, all right, in order to make these decisions, you can map out what data that you need to do that. It's a very worthwhile exercise. And then lastly, it's about insight. So talking about that simulation and rehearsal space, but with simulation and rehearsal, taking a sort of a cut of the paper processes that you have, moving through into the prediction and progressive assurance. So how can we use technology to not just look back and take stock of what we do, but to take a look forward? So these are the things that are areas where we're focusing on. And I guess on top of that, I was talking about survival and moving the business model forward. And this is from a piece of work where we're taking integrating work that we do in the capital investment space, so looking at ways of funding projects, making what we talk about capable owners, so making our buyers, our clients, governments and what have you, better procurers of data and technology, and being able to see that we need to create a different environment for our supply chain. And then lastly is that bit in between, so that integrator space. So how do we go about tying those two worlds together and delivering a more integrated type of service? So in terms of for example, having no contractual line between design and construction, for example, and exploring that. And I think especially so this was created in the context of helping governments get moving faster. I'm not sure I understand. Sorry, Siri. That's my Siri's made her a judgment on my presentation. where was I? So this was in the context of getting projects remobilized from the pandemic and being able to, how do you accelerate those programs? And accelerations is good because it's the same in terms of efficiency. It's just making sure that we're designing processes that are integrated and allow us to move faster. So and the pillars of creating the integrator came in two places. So there's the digital twin, all those decisions that we need to make and all the data that we need to collect and all the process mapping required to do that is one side. And on the other side is what we're calling about modern methods of construction, which comes on to the next piece. So this is the other pillar of our integrator, and splitting the design process into that manufacturing space and then creating that golden twin of digital, tying it all together. Hopefully it's quite fuzzy on my screen. I'm hoping it's not that fuzzy on yours. So an example of where we do this, we have a new business unit called Edaroth, which is an acronym for Everyone Deserves a Roof Over Their Head, where we've used this process to enable local governments to build modular housing on land that large developers aren't particularly interested in using. So we want to, we've created a housing developer that's going to create affordable housing that can be built very quickly. So we've got a generative design that feeds into a manufacturing process where they build. Our solution isn't volumetric; it's modular. So we have our kit of parts, and then that's assembled on site. It's one of the things that we're going to start looking at is how do we apply our collaborative robotics capability into that space. Collaborative robotics into that space. That's sort of into the future, just tying back to that original slide of moving from paper into connecting data and machines. And I guess it's there's no need to do modularization for modularization's sake. The thing that we focused on was how can we create affordable housing? What do you need to do to achieve that? Modern methods of construction is the only way to do that. And break down your design process for that. And so we go from end to end. So we created an integrator in terms of, it's a one-stop shop service in terms of you come to us and we do all the financial planning for the housing scheme. We design and build it, assemble it, and hand the keys over to the people that are going to be living in that. So as I say, breaking that process down into a process is really important, but do it in terms of focusing on a problem. So for those that saw Matt Gore's presentation yesterday, I was inspired by that in terms of, be focused on how can we reduce waste out of this process and think about you can do that and break those down. Now, here's the bit I want to leave you with. So Ali Mohar and I mentioned this paper yesterday. We worked together with Autodesk actually to create this report. It's about good data for the public good. And in there, we talk about where you need to go if you're going to be a data organization. And let's be real, all the things that we need to do are so data intensive that we need to think about what does a digital version of our organizations look like? And in front of you is a choice or places to look into to help guide your thinking in terms of where you want to go. And it splits into 4. Are you going to be a tool maker? Are you going to create your own technology to support your manufacturing and modularization journey? Are you be a tool maker? And that also means the same in terms of the manufacturing space. You will not need to have to go and buy warehouses and develop a manufacturing technique. People have already done that. You have to go out and think about partnering in that space if you don't want to make the capital investment. But then you have to think about, well, what's your role in that value chain? The other part is about being a market platform or integrator. So the integrator, that Edaroth example is a good one. How can I create a one-stop shop for something that's really complicated? In terms of the market platform, slightly different, and Amazon's more of an appropriate example. So for example, if you're going to go through the effort of integrating a supply chain, building an inventory to deliver loads of modular stuff like pumps and what have you, why not open up that platform to be a market for other construction products or other people that are trying to achieve just-in-time delivery and have control over their supply chain? Aerospace hasn't got it fixed. Aerospace has an interesting problem in terms of counterfeit products. in their supply chain and being able to track things that have, that aren't made out of the materials that they said they were, and etc. So, are you going to be a market platform or an integrator? The next one is about being a data holder or broker. So one of the things that's quite interesting, we think about Google doesn't actually hold that much data. It does more of a brokerage. So it indexes the internet and allows you to search it. It brokers people that has websites and people that are looking for things on websites. I think one of the mistakes that's happened in our industry over the past 7 years is that I think, and I come across this in lots of conversations, it's not about creating a master database that rules them all. It's always going to be a set of connected databases. So yes, there's value in holding data for a specific purpose, but somebody has to hold the data for us to integrate it. But that's not the be all and end all. There's a choice to be made. Are you going to be someone that is a master of connecting data and brokering the data, or are you going to be holding niche data that no one else is going to want to hold, and you hold the value and you connect it and create value from there? The last one is about being a technology hub. And I guess the analogy here is twofold. So you've got GitHub. GitHub is a tool that allows people to collaborate on code, and opens that up and creates a broader set of value. So, are you going to create an open source system for the technology that you're going to create, and your business is about the innovative ideas and implementation of those, and opening up to industry and creating a flourishing ecosystem from that perspective? Or is it like, one of the great things that Autodesk has done, for example, is in the Exchange. So create an app, creating integrated apps on top of your services, as you're opening up the capabilities of your technology for people to build technology on top of it. So those are 4 key areas. I think leaving today is one, we are in a fight for survival. And when I say a fight for survival, it is, lots of people have been on the manufacturing journey, and I don't think it takes much for them to go, why don't we build modular buildings? I think that's an interesting question that's on the horizon. We look at technology vendors. I mean, there's a bit of a cliche saying, oh, Google's going to come and eat our lunch. I don't think that's quite true. But if we look at the capabilities that come from automotive, and I think look at the technologies that are emerging from the likes of Dassault Systems and what have you. We've been through an implementation of Dassault Systems in civil engineering design, and it's quite interesting. That could be disruptive for this sector. Sorry, I've lost my train of thought. And then it's about your role in that, and thinking about what we all have to handle data. What is your role in handling that data? You're going to keep it, you're going to broker it, you're going to build technology on top of it, are you going to build a marketplace on top of it, are you going to use it as an opportunity to extend the scope of your business into that integrator? And it's lots to think about, but we need to do that to make sure that our organizations survive. And I thank you.
Thanks so much, Neil. That was an incredibly thought-provoking presentation. I genuinely wish we had time for some questions. I think that the space that you're talking about, in terms of data integration, data ownership, how we share data, like obviously Google is becoming an incredibly valuable company, the most valuable company on the planet, based on its ability to, turn other people's information and other people's data into a business model. And you kind of feel like there is just so much to be explored in that space. I wish we had time for it. I feel like it's actually going to be the content for a whole bunch of future forums.